Hello, welcome back to the second video then in this series on the particle model of matter. Now, as I mentioned at the end of the last video, what we're going to look at today is something called density. Now, you may have an idea what density means, but what I want to do today is look at the definition for density, the formula for density, and a few different examples and applications. So, density really just means how concentrated the mass of something is. For example, if you had a big branch from a tree that had fallen off maybe in a storm, and you found the mass of it, that would have a much higher mass than this coin here, which is made of copper. But does that mean I can say that wood is heavier than copper? Well, no, that's a silly thing to say because obviously it's going to depend massively on the dimensions of your object. And so we have this quantity called density. Now, is it true that wood is more dense than copper? Well, no, probably not. You'll find actually that copper is much denser than wood is. But because the coin is small, has a small volume, that's why it has a much lower mass than the wood. So officially then, the definition for density, okay, is the following. So density is, it's the mass per unit volume. Okay, so it really means how much mass is there in a certain volume. Okay, that's what that phrase means. Per unit volume just means per 1 unit of volume. So as a formula then, you might be able to work this out already, or you may know this already. So density equals mass divided by volume. Okay, there it is. Now, I will give this to you in symbols as well. Again, like I said before, I would go with the words because you're more likely to not make mistakes. If you want to go with the symbols though, that's absolutely fine. I mean, you'll be pleased to know mass is just a letter M, so that's quite logical. Volume is a capital V, quite logical. Density, however, that's not a P, it is a Greek letter. It's like a sort of curly P, but it's a Greek letter called rho. So rho equals M over V. Now that's why you've got to be careful, because if you put D there for density, you do run the risk of not getting the marks. So there it is in symbols, but do take care. Now units are a little bit more complicated here, just because there are two different common sets of units. So mass, ordinarily, we would say is measured in kilograms, as you know. And volume, we would say, is measured in cubic meters. Okay, now logically, that means that density is measured in kilograms divided by cubic meters. So in other words, density is measured in kilograms per cubic meter. Okay, so it's telling you the mass per unit volume. It's literally telling you, well, how many kilograms are there in every cubic meter of the material? Now, the difficulty comes when you're using or measuring, for example, quite small objects with small masses. So, for example, if I did that with the coin, the mass in kilograms is going to be tiny. The volume in cubic meters, I mean, think how small this is compared to a cubic meter. It's going to be so small that you get such a silly answer. And so there is an alternative set of units that is often used, because mass can be measured, obviously, in grams. And for smaller objects, it makes much more sense to measure volume in cubic centimetres. And that would mean then that the density is measured in grams per cubic centimetre. Now, those are the common sets of units. And so the reason I've done it in two colours there is essentially you either use the red units or you use the blue units. Don't go mixing them up. Check in any question which one's going to be more appropriate. And then you can go from there and use the correct set of units. Okay, let's look at a couple of examples then. All right then, let's go with example number 1. So, here I'm going to tell you then that iron has a density of 7.87 grams per cubic centimetre. And I want you to calculate the volume of a 200 gram piece of iron. Okay, so there's our question. Now, we're going to go right back to what we did in the previous topic, always the same sort of way of doing it. First step, write out the formula. Now, this is one of the formulas that you need to learn. You don't get given it. So we write out our formula as follows. Density equals mass over volume. Now, luckily here, we're using the blue units from above, look. Grams per cubic centimetres, 200 grams. I'll get my answer then in cubic centimetres. So density is 7.87 equals mass is 200 grams divided by volume. Okay, thinking about rearranging this then, probably the best way to think about it actually is multiplying both sides by volume, then dividing by 7.87, and I get my volume is going to be 200 divided by 7.87. But again, like I said plenty of times before, I'm getting marks here by showing all of my working. Okay, and so if you actually work that out, what you get, and I'm going to round it, you can see the numbers in my question are given to 3 significant figures. That's therefore what I'm going to give my answer to. So I get an answer of 25.4. It's the blue units, so that is going to be cubic centimetres. Okay, right, hopefully that makes sense. Let's try another one then. Okay, as if by magic then, there's question 2. So, a platinum block has a mass of 1 tonne and a volume of 125,000 cubic centimetres. Now, this is a bit of a pain, this one, because you can see it's not in one of our sets of units that we wanted. Now, we could go into, we've got this in cubic centimetres, we could put this into grams. However, 1 tonne is quite a large mass, that's quite a big volume. We're going to really be wanting to go to the red unit. So we're going to have to convert both of these. So let's see then what we've got. Well, 1 tonne, first of all. Hopefully you know that 1 tonne is 1,000 kilograms. So we can actually convert that straight away. Our mass is 1,000 kilograms. So that was easy to convert. This, though, is going to be a bit more of a pain. Now, I've done this on purpose because I wanted to just raise a point with you. You know, hopefully, that 1 metre is 100 centimetres. So if we want to convert from cubic centimetres into cubic metres, does it mean then that 1 cubic metre is 100 cubic centimetres? Is that true? Have a think about it. Well, actually, no, it isn't. Because if you think about going from cubic centimetres to cubic metres, 100 centimetres in a line, that's going to be 1 metre. But actually, if you're going from a little cubic centimetres, which is 1 by 1 by 1, into a cubic metre, you've got 100 by 100 by 100. So what you've actually got, 1 cubic metre is actually 100 times 100 times 100 cubic centimetres. Okay, and so actually, 1 cubic metre is 1,000,000 cubic centimetres. So in order to convert this 125,000 cubic centimetres, we want to get that into cubic metres, we have to divide that by 1,000,000. And so what we actually get then is 0.125 cubic metres. Okay, so always try to bear that in mind. Okay, right, I'm just going to get rid of this now then, because we're going to need to do our calculation. So I'm going to go to my formula. Density equals mass over volume. And now what we can do then is just put our numbers in, because we've already done all the conversion. So mass is 1,000. Volume is 0.125. Okay, and let's see what we get. Do always be careful to do your calculation the right way round. We get an answer there of 8,000, and we're using the red units from above, kilograms per cubic metre. Okay. Now, some sort of applications and things worth knowing, just very, very quickly. I asked you last time at the end of the last video, well, how do you think the density of solids, liquids and gases compares? Well, as you might imagine, in a solid, you've got a lot of particles close together. So you've got quite a lot of mass in a small area, small volume, sorry. Whereas in a gas, say, the particles are a lot more spread out. And so in general, okay, in general, solids have got higher densities than liquids, and they've got higher densities than gases. So solids have the highest densities, gases have the lowest densities. Now, it's not always the case. That is just a general rule. That's not always true. And in fact, that's what decides whether things float or sink. Now, you might be surprised to know that water actually has a density of 1,000 kilograms per cubic meter. That means 1 cubic meter of water has got a mass of 1 ton. Okay, so water actually is reasonably dense. And what will decide whether something floats or sinks is whether the density is higher or lower than the fluid it's in. So for example, platinum here with its density of 8,000 kilograms per cubic meter would sink if you put it into water, because that density is higher than that density. If you had something with a density of, say, 900 kilograms per cubic meter, then it would float because the density is less than that of water. All right, and that's what decides whether things are going to float or sink. Helium, for example, has a lower density than the average density of the air. That's why helium balloons rise, because they're effectively trying to float on top of the air. So that's a common application there of density, and in fact that is something that we'll come back to, the floating and sinking idea, something we'll come back to in more detail later on as we go through this topic. Right, I think that pretty much brings us to the end of density then, or at least end of the formula for density. What we're going to look at in the next video is actually there's a required practical to do with density, and we'll have a look at that and see how we can apply what we know. So I'll see you on the next video.